Hezy Washington, and I'll be presenting about the gas turbine. I'm going to give you guys a brief overview of what we'll be speaking about, some objectives of the experiment, the jet engine, the cycle, calculation results, and a conclusion. The objectives of the experiment were to understand the operating principles of the gas turbine engine, and we were asked to record data for various RPMs. The PDAC program recorded temperatures, pressure, thrust, and fuel flow at different points in the gas turbine system. And with that data, I had to make calculations to quantify different things at various stages. First off, the jet engine is like an ideal braking cycle. You have intake air. The intake air is compressed. This compressed air is mixed with the fuel and ignited. The hot air drives the turbine, which produces work and powers the compressors. And the air exits through the exit nozzle. It's also nozzle. The jet engine. The turbine engine is used to produce thrust. It's best to operate at high pressure ratios and temperatures for better efficiency. For the pressure ratio, you want to have a high compressor to ambient pressure ratio. The data that we're looking for, we were asked to solve for the mass flow rate of air, the thrust, the fractions of fuel, compressor work, and turbine work. Some useful equations. We use the first law to solve for the mass flow rate, assuming no work and no heat transfer. And it basically says the heat added is equal to the mass flow rate of air times the specific heat times the change in temperature. We were asked to solve for thrust, and thrust is just the velocity times the mass flow rate. The fuel fractions is just the ratios of heats, and the working pressure, which is also the mass flow rate times the specific heat and change in temperatures at different time periods. Some results I have for the mass flow rate. I used Excel to calculate all of this. I found that the average was about 0.3138 kilograms per second, and the standard deviation was about 0.0517 for the mass flow rate, and the thrust I calculated was about 7.72 pound-force, and the standard deviation was 1.04. As you can see, the thrust and the mass flow rate increased with increasing RPM. Some other results, I have the fuel fractions and the working turbine and compressor. As you see, they're equal, and the compressor is negative because it requires work, and the turbine produces work for the compressor. And the fuel fractions of combustion was shown too. Some possible errors I may have had was interpolation of the volumetric flow rate from the calibration table. Some data, I don't think it was like linear, so it's hard to do a linear interpolation for data that's not linear. And that affected my mass flow rate and thrust. And I assumed that gas was released to standard air. In conclusion, the measured values differ from the calculated values, as the real process is not ideal. Complete combustion did. For our calculations, we assume that complete combustion occurred in the combustion, which it actually doesn't. Combustion goes past that stage, so that's a possible error too. And we must operate at optimum pressure ratios, mass flow rate, and temperatures for maximum efficiency. Are there any questions?
Yeah, I got a question.
Yeah.
Your compressor work and your turbine work were equal but opposite?
Yeah.
It's supposed to be that way?
Yeah.
So that's all the work that the turbine was producing?
Well, that's what I calculated.
So, in my mind, that means the turbine's going nowhere. If it's equal, there's no work being overall
Well,
produced.
in the lab manual it says it's supposed to be equal too as well, so I'm not sure. I have my.
Because I know the compressor takes some work, like I don't know, 40% maybe of the turbine work.
I may, you know what? I may have forgot to add that work. I may have subtract that work from.
Because it seems like it's working for no reason.
Exactly.
Yeah.
That's what he's.
Yeah, I might need to check that. Good question. Any more questions?
Okay, I have a comment here real quick. Go back to, yeah. Hezy, what is the past tense for seek? What is the past tense of seek?
Oh, my bad. I was rushing doing this, trying to study for heat transfer, and so
You have to focus on everything. If you're present in, then people are going to look at everything. Not just the
Yeah.
results.
I just noticed.
Okay, any other questions? All right.
Thanks for calling me out, Jack.
Look at the results.